Here, good morning to all of you. I Kamaldeep, research scholar at MRSPTU Bathinda. Thanks to all of you for giving me such a golden opportunity. My presentation topic is 2-hydroxynaphthaldehyde based CIF-based tripoda receptor for terbium and gadolinium metal ions. This my presentation contains the introduction, brief introduction and synthesis, and the UV visible IR, H1MR, all the spectroscopic techniques, characterization techniques I have recorded, and the experiment on the ligand with the metal ion and in the absence and presence of the metal ions. Firstly, I am discussing about the synthesis. For here, for synthesis, there is a 2.88 gram 2-hydroxynaphthaldehyde and 0.25 gram 2-tris 2-amino ethylamine in 5 ml THF. Constant stirring at room temperature for 2 hours, and then we found a new ligand the of a yellow color and yield of 88%, melting point 198 degrees Celsius, solubility of the new prepared ligand in DMSO. This is soluble in DMSO and DMF, and partially soluble in ethanol and methanol, and insoluble, completely insoluble in the carbon tetrachloride and chloroform. After that, I have recorded the UV visible spectrum of the ligand in DMSO solvent. Here we have found three peaks for this ligand, two for the pi to pi star transition, and third for the n to pi star transition. Pi to pi star transition takes place due to naphthyl ring, and the imine group, double bond between carbon and nitrogen, and n to pi star transition takes place due to the CO group and and the cyanide CN imine group. ठीक है. And another IR spectrum of the reactant 1 and reactant 2 and the prepared ligand. Here we have found for in case of the reactant tris amine, there is a NH2 peak, higher NH2 peak at 2900, approximately 2900 to 2800 degree, 2800 nanometer centimeter inverse. And here for the benzaldehyde there is a CO peak at approximately 1600 to 1500, 1630. But after the condensation of the NH2 and CO group, we have found new reactant. There is no CO group and no NH2 group. There is no peak for CO and NH2, but there is a new peak absorbed at approximately 626 centimeter inverse for the imine group. This is the H1NMR spectrum. Here we have found the from 6.6 ppm to 8 ppm, all the four doublets and two triplets for the aromatic aromatic protons, and this is a doublet for the imine hydrogen at approximately that is at in the highly de-shielded region, at highly de-shielded region. This is experiments UV visible pH metric titrations of the ligand in the presence of the metal ion and the absence of the metal ion. Here this is the titration of the ligand in the DMSO water 70-30, in the 70-30 ratio. Here we have found that at lower equivalents of the hydroxyl group, there is no change in the UV visible spectrum. But at higher equivalents of the OH, there is a uh, pi to pi star transition at 256 nanometer is diminishes and shifted to the higher wavelength, that is the bathochromic and hyperchromic shift takes place, and a new band observed at 263 nanometer. Same will be happened with the another peak due to pi to pi star transition, that is diminishes completely diminishes completely, and n to pi star transition also shifted to the longer wavelength, that is 404. Hence we found two new bands at 263 nanometer and 404 nanometer with two isosbestic points. Here two isosbestic points are obtained at 302 nanometer and 366 nanometer. Here, as well as in the presence of the metal ions and in the presence of the terbium metal and the gadolinium metal ion, we have found the spectrum. There is a bathochromic, hence this bathochromic shift, and the in both cases is takes place due to the deprotonation of the hydrogen atom, deprotonation of the hydrogen atom. And the this is the this confirmed that the this is confirmed that the that the metal ion will attached with the, that is a like hence thanks.